Welcome to this presentation on functional programming concepts. In this session, we will explore key ideas such as immutability, pure functions, higher order functions, and more. Let's dive into the core concepts of functional programming. Functional programming focuses on several key concepts. First, immutability means that once a value is assigned to a variable, it cannot be changed. Second, pure functions are those that always return the same output for the same input with no side effects. Next, we have higher order functions which takes other functions as arguments or return them as results. And finally, referential transparency which allows us to replace an expression with its value without changing the program's behavior. Immutability is a cornerstone of functional programming. Once a variable is assigned a value, it cannot be modified. This reduces side effects, making the code easier to reason about. Immutability also enhances concurrency safety, as there are no shared mutable states that can lead to unexpected results. Next, we will discuss pure functions. A pure function's output depends solely on its input values with no side effects. This makes pure functions highly predictable, easier to test and debug. An example of a pure function is a simple addition function, where the result is always determined by the inputs and no external states are modified. Functional programming treats functions as first-class citizens. This means that they can be assigned to variables, passed as arguments, and returned as results. Higher order functions are a key feature as they take other functions as inputs or return them as outputs. For example, the map function can apply a given operation to each element in a list. Lambda expressions are anonymous functions defined inline. These allow us to define small functions on the fly, making code concise and readable. For instance, a lambda expression is in Haskell can be used to multiply every element of a list by 2, simplifying the operation. Lazy evaluation is a strategy where expressions are only evaluated when their values are needed. They can lead to significant performance gains, especially in large data sets. It also allows us to work with infinite data structures, where the elements are computed only when required. In functional programming, recursion replaces loops as the primary way to iterate. Recursive functions call themselves with modified parameters to solve a problem. For example, calculating the factorial of a number can be done through recursion, where the function calls itself with a reduced values. Here's an example of recursion in Haskell. This function SumList recursively sums the elements of a list by adding the first element to the sum of the rest of the list. The base case is an empty list where the sum is 0. Libs is another language known for functional programming. In libs, we can define functions like the factorial function using recursion. This highlights lib's powerful support for symbolic computation and functional programming. Let's compare functional programming to imperative programming. In functional programming, we focus on what we want to compute, while in imperative programming, we focus on how to perform the computation. Functional programming avoids mutable state and side effects, whereas imperative programming typically uses loops and changes states. Functional programming offers several key benefits. Modularity, since functions can be reused throughout the program. Predictability, as pure functions are easy to test. And concurrency, since immutability always allows for safer multi-threaded programming. However, functional programming also comes with challenges. There's a learning curve when transition from imperative to functional programming. Recursion and immutability can introduce performance overhead, and functional programming languages have more limited adoption in some industries. To conclude, functional programming emphasizes immutability, pure functions, and higher order functions, offering benefits like modularity, predictability, and concurrency safety. However, it may also present challenges such as performance and learning curve. That wraps up the presentation. If you have any questions, feel free to ask now. I would be happy to clarify any concepts.